I had just a couple clarifying questions on some of the exam stuff.
All right, cool.
So, first of all, just on the first one, the Cold Stone Creamery thing, on part B, when it says a flavor with 3 different toppings mixed in, how many different Cold Stone creations could there be? Are we assuming there's no repetition of toppings?
Yes. Right, I think, how was it defined?
Oh, 3 different toppings. Okay.
Is that how it was defined? Yeah.
Yeah. Now I see that. Okay.
Right. So, oh, here, I meant to share this and I never did. Right. So 3 different toppings. That's right. Okay.
Mm-hmm. And that also means it's also a random flavor when it says just a flavor of ice cream.
Yep. Just a random flavor. Yeah. And I think they said there were 16 of those or something. Is that true?
Yeah, 16.
Yeah. Right. And I mean, I kind of mentioned this before and I'll say it again. Part C, you just don't overthink it, right? I mean, the ice cream no longer matters. You know what I'm saying? That's like all I care about are the mix-ins, right?
Right.
And there are 3 of those. And so like if you and I, Summer, if you and I went to Cold Stone Creamery and I went and got my Cold Stone creation, whatever my toppings are whatever they are. I mean, it could be peanuts, gummy bears, and Reese's Pieces. And those become the ones, those 3 specific toppings become the ones that you kind of pay attention to. But you don't really know that, right? You're just doing a random one after that. And so the probability that you have exactly 2 of my 3 toppings, that's when you start the probability computation. You say, well, Hammett has these 3, whatever they are. There's like, 30 choose 3 ways that I could choose any 3 toppings, right? That would be like the denominator of the probability. And then I just have to count the number of ways that I could have exactly 2 in common with whatever Hammett had. That's the numerator. Does that kind of make sense, Summer?
Yeah.
I said that in a previous video, but I don't want you guys to be spending massive quantities of brain burning power trying to get through that one or something. Yeah.
And then I just had one more question on number 4, just to clarify, make sure I have the right initial values that you gave us. So let's see. It says the test detects HIV in a positive patient. That would be like the probability of HIV and positive.
No, that would be the probability of HIV given that they're positive.
Okay.
Conditional probability. So if I went to the pool of HIV, if I went to the pool of known HIV positive patients and gave them the test, the percentage of them that would actually have it would be 99.7%. Does that make sense?
Okay. Yeah.
So that's a conditional probability. Those are true positives. Yeah.
Okay. So wait, did you say that was positive given HIV or HIV given positive?
No, it detects HIV in a positive patient 99.7% of the time. So the probability that they will test positive given that they have HIV, right? Is that what I said, or did I say the opposite?
I think you were a little confusing, but yeah, I think it's positive given HIV, right?
Yeah. That's what I meant. Sorry if I said it.
Okay, I just wanted to make sure I got that right. Yeah.
Yeah.
It's among the pool. So I said for the pool of people that are known to have HIV, that's what you're conditioning on.
Okay.
If you give them the test, what percentage would test positive? 99.7. Yeah.
Okay.
Probability of positive given that they have HIV is 99.7. So those are true positives, right? Is that,
Right.
that's the
So
right?
the next one would be a true negative where it's given not HIV, it's not positive.
Yep,
That
yep,
second one there.
yep. That's exactly right.
Okay. And then the last probability you gave us was 1% of the United States is positive for HIV. So that's just the probability of HIV, right?
Yep. Mm-hmm.
Okay.
Yes. Yes.
Make sure I had those right.
And then this is, I mean, I don't know that I don't think it's any secret to you, but this is a
Bayes theorem.
Bayes theorem problem. Yeah. So you want to flip the conditioning around because, I mean, come on. You don't know the person has HIV before you give them the test usually, right? That's the whole point of taking the test. So they either test positive or negative, and you want to know what's the probability they have HIV given that they tested positive. Yeah. Which is kind of like the opposite of what you know at the beginning. Yeah.
Mm-hmm.
So.
Okay, so the three probabilities you gave us is the probability of positive given HIV is 99.7%. Probability of not positive given no HIV is 0.985, and the probability of HIV is 0.01.
Yep. That's
Okay.
exactly right. Yes. You should be able to write down the formula for total probability from that and then apply Bayes' theorem.
Okay. Sounds good.
Ah,
I had a couple questions, and the same question. For part B, like I did it, and I got an answer, and I'm pretty sure the calculations are correct, and I'm just wondering, like, I mean, I don't know what you can tell me, but my answer just seems like not realistic in a way. Like it seems like a pretty accurate test, and so I'm just wondering why my answer is the way it is, and I'm not sure if I should be concerned about.
no, it's. I think that you're right. This mistake has literally been made before, Joshua,
Okay.
where people think the tests are pretty accurate, but the problem is if you have a really small pool of people that actually have the ailment,
Yeah.
thing needs to be more accurate than you realize.
Okay.
Like
And then
95 and 99 or something. So the answer I'm telling you should be surprising. You should go, what?
okay.
You know? So yeah.
Yeah, and then my other question was just part C. Like, I was just trying to understand like what you mean by do you believe your answers will still be accurate? Like, because obviously it's just a calculation, but do you mean like how accurately would it be predicted, or
Well, so the question is someone who takes the test a truly random person?
right? No,
Someone who tends to take the test, are they truly random?
right? They think they might have it. Is
Yeah. So in all likelihood, it'd probably be more like what would happen if you administered the test on the pool of people that do have it. Does that make sense?
yeah.
So it's no longer like truly random.
Mm-hmm.
So all of the computations that are done in B are done based on the, I'm going to pick a random person from the United States and give them the test. But in practice, that's not really how this works. You know what I'm saying?
Do
People,
you just want us to like explain what would happen if it was voluntary?
yeah. Would you expect it to be a higher probability? Would it be the same? Would it change? Right?
Okay.
So, yeah. Does that kind of make sense?
Yeah, that makes sense.
Well, anything else? Is Madeline still in here?
Yeah, I am.
Oh, okay. I just lost your picture. That's all right. Well, hey. All right, cool. Nothing else?
I just want to clarify about 4A. So basically, all we're trying to find is the probability that it's a positive test, not that And we don't know anything about the person, whether they're positive or negative, just that the test is positive, right?
Let me look again for a, no, I think, oh, this is the probability.
You mean like probability of positive?
Yeah, like the probability of the test being positive, and we don't know anything about the person. Because it's a random person, we don't know if,
Like just given to some random person, what's the probability they'll show
Yeah.
up positive?
Yeah, that's right.
Okay.
So you're just trying to
Okay.
find the probability of positive. Yes, that's right. And what I'm saying is you should be able to determine that by the formula for total probability, right? So. Well, hey, what else? Okay, well, hey, it's been fun. I like teaching math. I hope you've liked taking it from me. So, sorry that things are a little messed up here at the end, but try to make the most of it, I guess. Appreciate you guys coming in and asking questions. It always makes it a little bit more fun for me, for sure. It's better than staring at a screen and not getting any feedback at all. Okay. All
Will
right.
you be available to answer any questions on Wednesday?
Yeah, I mean, I'll continue to keep office hours throughout the week. So, yeah. So like on Wednesday, I'll try to still keep my normal like class time hours. I don't have office hours on Wednesdays because I have something else going on, but I'll still come in during class time.
So this time slot.
Yep. Yep. Yep.
Okay, cool. Thank you.
You guys good to go?
Yeah.
Think so.
Hey, thanks a lot. Go ahead.
Thank you.
Make sure
thank you.
the evals if you haven't done that yet.
Already done.
Always trying to convince students to do that. So yeah. All right. See you guys later.
See ya.